All right, we are getting ready to kick back up here. Hopefully that break was long enough to grab a cup of coffee if you're joining us from the West Coast, or maybe even grab a beer if you're joining us from Europe. We've got attendees from all over the world. Next up, we are going to be having a panel discussion on exascale storage. I've asked Mr. Matt Starr, who is Spectra's own Chief Technology Officer, our CTO, to lead the panel and introduce our participants. So Matt, I will turn the floor over to you.
Great, thanks Bob. And back to that last presentation, there was an interesting thing that I think that was said, which was reducing your backup helps protect, your data from an aspect of, how do you keep it from getting virus and malware. That was an interesting comment that I thought was kind of important to reshare.
Right, just a cleaner data set, easier to manage.
Yeah. Yep.
Agreed.
Yep. So we're the Exascale panel. We have Robin Goldstone from Livermore National Laboratories right here. James Thompson from Los Alamos National Lab, and we have Matt Ninesling from SpectraLIVE. He's our director of tape profile. So we're going to be talking about exascale storage. Really, what does that mean to the ecosystem that's out there today? So I'll start with you, Robin. What is exascale, especially when we talk about storage? What does that mean to you?
So sure. So generally, I mean, when I think of exascale, I typically think about the compute capability because that's the thing that we're working towards. So exascale computing being an HPC system with at least an exaflop of performance. We have several of those systems in the works across the DOE and NSA complex. Argonne and Oak Ridge are both looking at getting exascale class machines in the 2021-22 timeframe. And Livermore has a machine following a year behind that's now targeted to be over 2 exaflops. So, and of course, it's a global competition. So right now, last year, there's a half an exaflop machine announced by Japan. And so there might be somebody who tries to leapfrog us to that magic mark. But yeah, so when I think of exascale, it's mostly compute. Of course, we do have storage requirements going along with them. Maybe later I'll talk about sort of those ratios, but I'll stop there for now.
Okay. And Matt, how about outside of HPC, what's happening as far as, exabyte storage?
I think, you look at like the media and entertainment industry, and now you're shooting stuff in 4K or even 8K, and it's going to be even larger file formats going forward. That's huge amounts of data when you look at a full motion picture or large sporting events. You look at like the Olympics happening, that kind of stuff. So that's going to create more and more content that you can never really get rid of the original footage from it. So they're going to want to keep that forever in their archive, and it just gets larger and larger and larger. You look at like autonomous driving and what they're doing with AI and how they're working on those algorithms to refine it and get it better and better, so we actually get to the point where you can have cars that drive around by themselves. Huge amounts of data, and they want to keep all the raw sensor data, all the input data essentially forever, so they can go back and build off those newer calculations in the future. So it's all over the place. You see places like CERN, when they turn the collider back on, the new sensors, they have to filter it tremendously already just to get it onto disk, never mind going to their archive, because it's such a huge amount of data coming off the collider. It's all over the place at this point in terms of the scale that gets us to an actual exabyte of data in an archive.
Yeah, it was interesting. I had to get an x-ray, and the guy showed me the x-ray, and it's now all digital. And a bone has very small holes in it, and this x-ray, the resolution of it, you could see the little holes in the bone, and you think about what the data that digital x-ray now is being stored. My x-ray will be stored for 20 or 30 years or more. So yeah, we're seeing not only resolution go up, speed go up. That basically gives up 4x or 8x data growth. So okay, so is it realistic to store an exabyte? And Robin, I'll give that to you first. Do we have to store an exabyte, or can we just?
I think not. I mean, are we capable of storing an exabyte? Definitely, right? So when I talk about our computing scale growing larger, obviously the larger the machine, the larger the capability. Either the more calculations you can do in a given amount of time, or the higher resolution calculation you can do. So they're always wanting to do higher resolution calculations which generate more data. But the feasibility of keeping all that data I mean, economically, it's just not there. We just can't afford it. So if you look at our current sort of, top 500 supercomputers, Sierra, it's number 3 on the top 500 list. It's about 125 petaflops, and we have a 150 petabyte file system that goes along with it. So that's almost sort of a 1-to-1 flop to byte ratio. When we look ahead to our next machine, El Capitan, which, as I said, is projected to be over 2 exaflops in capability, right now the file system is only targeted to be about 3 times the size of the current file system.
So that's 10 to the 18th flops, right?
Yes, yes. Well, I'll trust you on that. I will. But basically, why isn't the file system growing at the same rate as the compute capabilities? Economics. We just cannot afford to build that big of a file system. So users need to change the way they do things, and they need to change the way they do things not just because we can't afford to store it all. It's because if they wait till the very end to process and analyze that data, it's just too much data for them to even go through. Users are going to need to and are starting to develop capabilities to do what we call in situ analysis, to analyze data sort of as it's being generated so that they don't have to store everything and then come back at the very end to analyze it.
So it's very much getting rid of that intermediate result, and if you have to go back, maybe recompute.
Yeah.
Okay. Yeah, we see that in media and entertainment a little bit, Matt. But are we seeing media and entertainment getting rid of data?
We really aren't, especially if it's the actual capture data. You think of it as like the actual initial filming, right? They may get rid of the edited data in some cases, or be able to, not keep all of it. And I think that's a big difference kind of in what Robin talked about, in that capture data is one thing, and you can never recreate that data again. And that could be from a satellite and for meteorological purposes. That could be a video that's filmed. It's never going to happen exactly like that again. That could be a collider somewhere. So that data is very valuable, and you can't just run the simulator again and get the same output, right? So there's a big difference between output data and capture data in different use cases, whether it's M&E or it's physics or, all the different industries out there.
Yeah, that's a really good point. I'd like to just clarify that. Yeah, so for traditional HPC, the crown jewels, the thing that's of value is the source code. That's the application. That's the thing that you would have to rewrite from scratch if you lost it. And that's very small, and that's the thing that we would archive. The output, which is very large, you could always theoretically recreate it by rerunning the problem. For some of these other disciplines, it's the input data that's valuable, and for things like film, like Matt talked about, also for machine learning, where we have some big, huge data set that we're getting in, and that is a thing that we have to preserve that cannot be recreated. So that's a really good distinction.
James, how about you? Anything at Los Alamos that are you guys getting close to an exabyte? Do you see it in your future?
As far as compute capabilities, we're moving towards that. As far as the storage capabilities, we're probably around 100 petabytes, and so we probably won't be hitting, an exabyte in our archive, in the next few years. It'll take some time, but we'll be moving towards that, of course, once we start getting larger and larger compute systems going here.
Okay, so when we talk about this 100 petabytes or a couple hundred petabytes, and Matt talking about customers with 500 petabytes, what are the technologies? How much disk, how much tape? What are you thinking about as far as what's new? Where do you store the bulk of your data? And James, I'll throw that to you first.
Yeah, so we tend to have most of our archive on tape. We have a relatively smaller disk cache that things get sent to initially, and then it gets migrated off to tape. Some of the other labs, tend to have a larger disk cache where they try to preserve that, but we tend to be more tape-based as far as where the archive ends up.
Okay. And Robin, how about you? I know that you guys are a large HPSS user.
Right. So again, there's the archive storage, and there's the whole hierarchy. I mean, basically, people, when they're computing, they need their data, obviously, to access it very fast. It's in DRAM. From there, they would write it to the file system, and from there, eventually, if they need to preserve it, it would go to the archive. But now, as I mentioned, people wanting to do in situ analysis, maybe they need another tier of storage that's faster and closer to the compute, so that's where we're looking at flash some of the architectures we're looking at have flash storage either in the nodes or nearby where users can, store that data at a transient level while they're analyzing it. But yes, eventually it does go to the tape archive. Our total capacity, we have 2 different compute environments, and we have about 300 petabyte capability in our largest environment, our classified environment, and another 150 petabyte tape archive today in our unclassified environment. And James talked about a disk cache. We do use HPSS, and historically, traditionally, the cache has just been the place, traditional definition of a cache. That's where the data lands and sits just long enough to be able to flow it out to tape. But we've made a conscious effort to actually grow our disk cache with the goal of keeping people's data resident in there for a year. So if they do have to restore their data, they're not having to wait on tape mounts, because obviously that's the big complaint about tape is the latency to first byte to getting their data back.
Yeah, I should have reiterated. HPSS is the high performance storage system. It's one of these HSM file extension systems that is commonly used in the DOE, commonly used in large archive sites, including weather and HEPICS, high energy particle physics. It is what I would kind of consider the Mac Daddy of archiving software. It's the one that scales to, it's the one that probably will be the first one to get to an exabyte of data, I think. So when we think about this, okay, we have an exabyte of data. It's not one file. It's not one big exabyte file. You have tiny files and you have some really large files. I know that Los Alamos, I heard at one time you guys had 7 files that were over 7 terabytes, maybe going bigger. What does your file size look like, and what are you doing with tiny files? Notoriously, tiny files chew up a lot of file system space, and maybe tape isn't the right place for them. What are you doing with those, with your file sets? James, I'll throw that to you. Okay.
Yeah, I mean, so as Robin mentioned, we use HPSS, and so part of that software package, it does, file aggregates, and it just depends on the programs that are being simulated, whether they're creating, millions or almost 1 billion files in a single directory, or it could be, multi, 100 terabyte file or larger. So you kind of have to deal with a wide range. And when you're dealing with a lot of small files, obviously the big issue there is just dealing with the metadata and that type of that type of thing as you scale can start causing some issues.
Well, and Matt, I think, oh, sorry, I was going to say, I think, you talk about HPSS and its scalability. Lawrence Livermore, you guys are almost at 1.5 billion files in both the secure and the open site. So how do you use that? I mean, how do you actually know what your data is and where it is and make it usable, right? I mean, that's a ridiculous amount of files out there.
Yeah, that's a good question, and it is true. I was going to point that out. I saw a presentation from the HPSS users group recently, and we are one of the top 3 sites in number of files. So typically there's a couple of different models that these HPC applications use to store data. In some cases, they write one big shared file, so there's a file that all the processes open at the same time. They all seek to a different place in the file, and they write to that location, and they end up with one big file. Then there's sort of what they call a file per process model, where every task in the parallel application opens its own file, and that's where you can end up with millions of files. So for us, metadata is the biggest issue. The performance of the metadata whether it's a file system or the archive, being able to create that many files, and then, like you said, what do you do with them? How do you list them? And then, of course, the inefficiencies of storing small files on tape. HPSS, we have utilities. We have a utility called HTAR, which is like tar, if you're familiar with, for Linux. It lets the users take a collection of files and manipulate it as a collection. Ultimately, the individual files are being written to tape, but they're being written together as a group, and that lets you get more efficiency when you're writing to tape.
How well trained are your users to use HTAR? I always hear, and this isn't a question but it's just one of those things I hear, especially from HPSS vendors, the scientists don't like HTAR. So we have to do that for them. Have you got that automated yet? What are you doing to bundle up those files? Or
Well, we have multiple interfaces, and we've developed multiple interfaces over time because some of them perform better, some of them are easier for users. We have graphical user interfaces, we have interfaces that concentrate on more parallelism, and every user is willing to use something different. Some of them don't like any of them at all. We're currently working on a Fuse interface, which has existed for a while in HPSS but wasn't heavily used. So a Fuse interface basically lets the archive look like a file system, and that's an interface that users are familiar with. They can CD into the archive, they can LS, list their files and whatnot. The problem becomes when they start doing operations that might trigger a whole bunch of tape mounts. You don't want,
like
in Linux, Linux lingo grep, you don't want to trigger a lot of tape mounts. So we've been working on enhancements to HPSS that can tell when a file is on, on tape versus maybe available in the disk cache. So that's another place where our large disk cache comes into play, because if users are looking for recently written data, and it's in the disk cache, then they can take advantage of those common, Linux utilities like grep to look through their data. So we think that's going to help some number of users manage their.
Yeah, I saw on the Huff, the HPSS users forum, that somebody had actually written a shell to actually prevent what we're talking about right there, which is, the rogue scientist says find ..-print pipe to grep, which would say find everything and go search for this string in everything.
Right.
That would be a lot of work. So when we think about, as you're progressing up the scale from, 100 petabytes to 500 petabytes, possibly going to an exabyte, what do you have to think about? What's changing as far as your capacity growing, tagging your data? How about search? What are you thinking about when your data is growing, file count's growing, file size is growing? James, what are you thinking about?
As things scale, problems that you're only dealing with, once a week, if you go from 100 petabytes to, an exabyte, are you dealing with them 10 times a week? Are your problems going to scale, the same way? So some of the issues are, going to be that I'd be concerned about is, what about technology migration? Obviously, we probably won't be, if we're growing to that size, are we moving off of, say one tape technology to another, and how's that going to work out? Are we going to be able to continue to scale the performance of both migration and ingest and recall? So it's all the things that are current issues. Do they get worse as we start scaling up to an exabyte size file system?
Yeah, theoretically 10 times more power and 10 times more connectivity and 10 times. Yeah. So Robin, how about you at Livermore? It's the same data set with the same, or 10x the data set, 2x the data set with the same number of users. What's happening around that when the set grows, and how do you fix search? How do you fix?
Right. Right. So not, James talked about sort of the operational side. Again, thinking about users and finding their data and whatnot. And you mentioned tagging. You also mentioned HSM. I want to touch on that real quick. But what we want to do is just help users say, where is my data, right? And in a lot of cases, if they don't remember where they put their data, sometimes they'll make multiple copies of it in separate places just so they always know that it's where they might want to find it. So finding tools that we can provide to users to help them manage their data and organize their data. So we're looking at a particular technology that we hope is going to let users tag their files by metadata that means something to them, not typical file system metadata. Today they use file name as their metadata. It's the only way they have to identify a file. So they have a file name that's 50 characters long that has the name of the code they ran and the version and what node they ran on and what date and what, all this stuff. So finding ways for them to create those tags and then ultimately be able to use those tags maybe to trigger migration. So you mentioned HPSS is an HSM tool, which is a hierarchical storage migration. Yeah. And that's actually a pretty robust capability. I'm not sure, but I think IBM was really the first ones to coin that. And the idea was to have sort of an ability to do automated migrations through tiers of storage. That's not how we treat our archive today. Our archive today, users have to explicitly move their data to the archive. They have to say, I want to archive this. And then the tools that they have are interactive tools, so they have to sit there and move a file and wait till it's done. And maybe they can say move the file and FTP the file and go to lunch and come back. But what I want to have them do is have the ability to tag files by what's meaningful to them, and then have an automated system that comes along and that archives the data for them. And maybe sends them an email when it's done, or some other type of notification. Users just want to know that their data has safely made it to the place where they know that it's safe long term. And for me, helping users manage their data going forward is just going to be critical, because the manual tools that we have today, I just do not think are going to continue to scale.
Yeah, I would agree. And that metadata capture, I always say to people, the worst thing you can think about is a file name as your metadata, because you're storing it in a context of the moment, right? You would want to type in, if you were on vacation and you took pictures, you'd want to type in where you were, the year, maybe the kids that are in the pictures and things like that. Not, Colorado, spring break, it's very hard to find that way. So yeah, I think that capturing the metadata on the front end is one of the most important things you can be doing.
Right, and keeping data, and putting that data in a database, in a piece of software that's actually designed for search. Today, people use the metadata server of the file system, of the archive, as their search tool, and they are not designed for that.
No, it's a directory open. Yeah, very expensive. Yeah. So Matt, outside of HPC, what are we seeing as far as search and who's successful at it? Who's doing it today? And I think I know of a couple verticals that are kind of ahead of metadata tagging. Who is it?
I think M&E does a pretty good job of it, because they have to, and they know that they're going to go back and use that data again. They're going to make a sequel to a movie, or they're going to re-edit it in a better format in the future. So they need to know how they get to different pieces of it, different cuts, different parts of, some movie that they shot or something like that. So I think they've always done a pretty good job of tagging compared to some other verticals. I think that, your general IT is probably not one of the better ones.
Right.
It's probably about the worst, and it's probably hardest to go find an individual thing, right? Unless you named your file well, and that's kind of how you're searching for stuff. I think it's more the disciplines that know they're going to use the data, true archive functionality versus just like backup type stuff.
Yeah, I think the only other one I was going to add to M&E is machine generated data sometimes, because they can type in information about the experiment, about that microscope, what it's running against, what that genomic scan is. So some of the metadata is there. It's interesting. I had a customer and I said, do you store the firmware version of your equipment in the metadata? And he said no. And it was, well, that firmware is important, because just like you said, the code that runs against the HPC, that firmware could have a defect. And if you need to go find every scan that had the defective firmware, you need to be able to go find that. So let's step forward a little bit. If you think about storing this much data, the cloud. Go to the cloud.
The cloud, sure.
So the cloud is it, because it's pixie dust, and it just works. So Robin, why isn't Livermore storing this much data on the cloud? What prevents it?
Well, fortunately, there were many speakers before me who talked about the challenges of cloud and the economies of scale and the cost model. And it just really, the cloud vendors, they're happy to take your data and ingest it for free, because they want you to compute in the cloud, right? And unless you're prepared to compute in the cloud, which last time I checked, they did not have a top 10 supercomputer in the cloud, right? When you want to get your data back, that's when it gets expensive, even for their sort of cold storage. I was just looking up the pricing model for Amazon Glacier. But the other thing is, again, the bulk of our computation, our big systems are in our classified environment. That's where we do our national security work. That security level, there are classified clouds, there's a DoD cloud, but their classification levels are different than ours. Ours being NNSA, the National Nuclear Security Administration, which is basically Los Alamos, Sandia, and Lawrence Livermore. There is not enough of an incentive for a cloud builder to build a dedicated cloud at our security level that we need. So, and we need the same environment. We want our users to have the same the same sort of tools and experience across both of our environments, classified and unclassified. So it does not make sense for us operationally to do something different on our open side where maybe we could push data to the cloud, and on our classified side where it's not feasible. So that's some of the considerations. Yep. There's more, but let James get something in on this.
James, how about you at Los Alamos? Any?
Yeah, I think part of the issue, having dark sites where we can't disclose, we're not going to upload things. It's already difficult enough just to transfer a small amount of information out of the classified area. Also, some of the cloud technology, we tend not to do much with object storage. A big flat namespace can have security implications. We don't want someone to be able to just, browse the entire namespace for what's being, stored in the classified network. So there's not really a compelling reason to move to the cloud for some of the work. There might be for some other things, but probably not for the main bulk of the computing that's being done right now.
So Matt, what about bandwidth and cost of pipe? Do we ever hear that from customers?
Yeah, and that's one of those extra costs that if you think about, if you have an on-site archive, you can just say it's on tape, add more tape drives, right? You get 360, 400 megabytes a second a pop, and you just put more tape drives in. It costs money, but you can keep adding more and more of them if you want to. It's pretty hard to just say, I need another 10 gigabytes a second over my network bandwidth to the cloud for the next 2 weeks or for the next month or whatever that is. And that costs a lot of money. It's not something that you can just flick on and off typically.
Yeah, nobody gets dial-a-WAN, right?
No, that you can just tune as you need it on a regular basis. I think the other piece is, you guys have the security issues involved in it, but it's also that archive is possibly one of the most important things to the organization, right? That data set. And do you trust it with somebody else, even if it is a very well-known cloud provider? Do they care about it as much as you do? The cloud might be a great place to put a second copy that you're not accessing, that you're not using bandwidth costs, that you're not, you're only paying the storage bill for, not the access bill for. And that might make a lot of sense because you get geographic, differences in where the data is kept. But, for your primary copy that you use as a, and a lot of sites now use their archive. The data is coming out on a regular basis, not just going in. In that case, it may not make a lot of sense to be able to say that's my copy that I keep in the cloud.
Yeah, there's the class, Ed Childers, a friend of mine, he always said that if you need as much power as a power plant will provide, you should build your own power plant. And you guys really are, when you talk 100 petabytes, you're deploying technology, the same technology with the same software stacks or similar software stacks that a cloud vendor would be providing, except you get to tune it, you get to set the SLA for the data. You're not meshed in with hundreds of other customers. So how do you protect? If you think about, if we're going to go to an exabyte, how do you protect it? What do you do if it's going on to a single copy? What do you do? And Robin, I'll throw that to you first. You guys run HPSS. What's HPSS doing to help you with that?
Right. So, in general, tape technology itself has high durability. HPSS adds a lot of resiliency on top of that. We've been using HPSS for a very long time. I meant to check on this because I'm not the actual HPSS administration owner, but I don't believe we've ever lost anybody's data. Okay, and we go to great lengths to make sure we don't lose data. In terms of protection, basically any file that's smaller than 256 megs, we automatically make 2 copies of, and that's to protect against, say maybe a bad tape or something like that. For larger files, we actually let the users decide that. So we have a class of service that provides replication, and for that we actually use RAID, which is RAID on tape, and that's another feature in HPSS that I don't know how widely it's used, but we definitely see value in it as a way to provide an additional level of protection for data. But we've restored data from 50 years ago.
Wow.
Yeah.
So that RAID set, that's 5 tapes or 8 tapes a plus 1 or 2 in a data set. So you really are talking about that you could lose a whole tape in that set and still recover data.
Yeah, I'm told we're doing 2+1 to minimize too many tape mounts,
Okay.
but it's still better
Yeah.
than,
Yeah.
one. So,
Yep.
yeah.
Okay. James, anything to add? I don't think Los Alamos is using RAID or anything like that. What are you guys doing? Multi-copy?
It's similar, yeah. For certain file sizes under, it might be a gigabyte, I'd have to look at the exact rate, but yeah, we do tend to do 2 copies, and then some of the larger data sets, there's only one copy on tape, so that we have to make sure that that things are that everything's safe and secure.
Matt, any
so
other?
We'll be looking at.
Sorry.
What was that?
No, go ahead. I'm sorry. You'll be looking.
Yeah,
at,
and so we'll look at we always continue looking at other things to see what makes most sense for our current users. But that's how we're currently set up, is with for certain file sizes we do 2 copies, and then for the larger files there's just 1 copy on tape.
So Matt, we heard from Alan Hall doing a copy in Asheville, and he has a current copy in Boulder. He's going to move that copy to the cloud. Hopefully never touch it. Any other customers out there that you can think of doing something kind of unique geographically? Is anybody else looking at rate? What's happening there?
Well, and I think historically, best practice for tape was write 2 copies and keep them in different places, right? And that's the safest way you can do it. And one might be in a vault somewhere, or you might have libraries in separate places, like Noah was doing. As you scale bigger and bigger and bigger, obviously the costs associated with that maybe get to the point where it's not feasible anymore, or it's a lot more than you want to spend. Things like rate make a lot of sense. I think we'll actually see in the future, more true type of, erasure coding type algorithms that are used with tape across multiple libraries possibly, to disperse the data, over a wider number of tapes and give you the safety of not having it on a single piece of media, but also not having to write 2 copies of all the data, so you get the economics of it as well. The cloud, like Alan Hall's doing, that's a great use case for cloud, is to put that second copy in the cloud. That might make a lot of sense in a lot of instances, as long as you're not planning on using it.
Well, he's using the lowest level,
Yep.
12-hour retrieval. So if he did lose a piece of data, he could pay a little extra to get it back a little faster, or he could wait the day and get it.
It's true disaster recovery, right? I think I heard Alan talk before, and I think his term was a smoking hole in the ground is when we'd go access that data type, right? And
a big checkbook.
Makes sense, right? Yeah, exactly. But it is really just if something terrible happened, I didn't lose it.
Yeah, it's interesting. I think the other one that I'd bring up here is the Large Hadron Collider experiment. I don't want to call them erasure coding, but they really do spread the data across the world, so everybody has a little bit of the data, not one side has it all. They're selling. So not one site has it all. They've almost erasure coded across many sites where the data can be moved, and you could actually pick it up if, for example, if Brookhaven was not available at the time, you could possibly pick it up from somebody in Europe and pull some of that Large Hadron Collider data out. So when we think about exabyte, exascale computing, growing these data sets, what technology are you looking at 5 years down the road? Are we of course flash is going to start taking over for spinning disk, we think. Are we looking at flattening the pyramid of storage? Are we looking at making it steeper? Robin, I'll take that to you first. 5 years, and by the way, I know you're retiring in a few months, 6 months from now. But if you could picture someone else's future of a pyramid or what is it, what's it going to look like in a few years? What's the technologies?
Right. Well, I think another speaker said, tape is not going away. We do not see tape is going away. We just made an investment in Spectra and in refreshing our tape archives, and we have a lot of ability to expand capacity. So I think tape will continue to serve the role that it's been serving. I think on the other tiers, we actually we just did a large disk procurement and got very attractive pricing on disk, and we can use that disk for our disk cache, our disk cache for our archive. We can deploy that disk as parallel file systems. Lustre is the one that we currently use. We can actually deploy that as dedicated storage if there's a project, a customer who lands some big, huge data set and they just want their own copy of it. we can give them that. The flash, you know, it remains to be seen. I mentioned we are starting to deploy flash as another tier. And again, for some users, they really want that. Other users are like, no, there's enough tiers. We don't want it to be that complicated. So in that model, I think we have to look at some sort of automation that helps them migrate their data into all those tiers potentially transparently so that they can integrate it in their workflow. Users don't want to deal with I/O, okay? In our environment, they have, we're just starting to get systems with GPUs. They're spending all of their time optimizing their applications for GPU. They have a certain tolerance for how much time they want to spend doing I/O, and as long as they can get their I/O done in that time, they will avoid, you know, tweaking their I/O patterns. So I think we have to continue to try to make I/O, you know, work for them as transparently as possible. I don't see a lot of huge new technologies. There are some, we are looking at a specific file system technology that's making use of low-cost flash and getting down to a point where it really is potentially viable as a replacement for disk, but I don't see that as being sort of possible.
Do you see Crosspoint coming into the supercomputer, the Crosspoint, the non-volatile memory, so you snapshot locally, or is that way off into the future before you deploy? Because when you take a snapshot or a memory dump, the whole idea of checkpoint is so that you don't have to go back and recompute for weeks. You can come to that checkpoint and restart it. Are checkpoints going to be going to solid state? Or inside?
Well, again, there's Crosspoint, the memory technology, there's Optane, the memory technology, and there's Optane, the flash and NVMe technology. That one's hard to say. I mean, we do have, I think Argonne is getting some of that in their next big system. But the problem is now, DRAM isn't even fast enough for users for compute. They're running on the GPUs, their memory, they need GPU memory. So even the latency of having to get data out of DRAM is going to be too much for them in the future. So anything that's higher latency, you can't view, I don't see us viewing something like Optane as a memory technology. As a storage technology, fine. But again, that extra latency, our users are not going to even necessarily want DRAM in their future systems. They're just going to want HBM. So.
That's interesting about the GPU because just for general IT, they think of GPU as the graphics card that their kids are playing a game on. They got, a few thousand cores and 32 gig of RAM or something like that. You guys are using that for compute because it's great at math. It's great at vector math.
Right. So in the interest of transparent data movement, I mean, there are some interesting technologies, GPU direct storage, for example, from NVIDIA that can move data from the GPU memory out to storage, something like NVMe flash, without using CPU cycles. So things like that can help users take advantage of slower tiers of storage, sort of transparently.
Yeah. James, how about Los Alamos? What's happening
there? Yeah, in the next, 5 years or so, I really don't see a, huge change in what's being done. I think, Los Alamos, they tend to be, try to be really good stewards of the budget and the taxpayer money. And so, unless something comes along that's, significant cost and performance advantage over what's currently in use, I kind of see just kind of an increase in what, just an add-on to what's currently being used rather than some kind of wholesale, change out to some new technology.
Okay. So how about interfaces? We talked about storage technology, we talked about flash disk, tape, we talked about Crosspoint. What about fiber channel, IB, and Ethernet? What's happening on that front as far as connections? Are you seeing a convergence, or are you seeing new technologies that you're thinking about?
At Los Alamos, we definitely are looking at some other things. We've been evaluating, there are moves now since Ethernet has gotten so, has gotten so fast that, is that a replacement for fiber channel? I still think we'll probably end up using fiber channel for, for the next few years for sure. Maybe it'll stick around. But we've been investigating, looking into, doing, some of the, using some of the other interfaces as your storage backbone. You can leverage, you tend to have a lot of people that are very skilled at the lab in in the switch technologies, Ethernet and InfiniBand, do you leverage that by moving off that platform and not having to deal with, the dedicated fiber channel? But fiber channel is, nice and robust and does a good job in what it does. So it's definitely not a clear cut that, oh, we're definitely getting rid of fiber channel, but it's something that we're investigating if it makes sense, because not everyone has the skills to deal with fiber channel networks and provisioning.
Yeah, I think today in today's world, it's tape being one of the last technologies that is fiber channel in the data center. We do have, Matt would I think agree with this. We do have customers that have never deployed fiber channel, or it's new to them, and they are looking at Ethernet technologies. I would say HPC is one of the few that use IB and InfiniBand, but Ethernet, and I'll let Matt jump in here. Ethernet is, I think, going to be the more common wire in the next 5 years.
Well, I think especially if you look at newer protocols over Ethernet, right? So, it's not just iSCSI anymore. If you look at something like RDMA over converged Ethernet, Rocky, that really is very, very similar to InfiniBand, which for HPC has been used for a very long time as a high-speed interconnect. It's that same base ICER technology. So if you can move that onto a very fast Ethernet backbone, it might make a lot of sense to commonize on a similar type of switches, knowledge base like James was talking about, in terms of people knowing how to manage that infrastructure better and not have to have, different technologies in your data center if you don't have to in the future. I don't think it's quite there yet, but it's very, very close. We've been doing some POCs with our Swarm product, and it works. It works very well, and you get to use all that same infrastructure again that you're already using with the rest of your Ethernet stuff. So it's, this year into next year, I think we'll see more and more movement into that area. There's also, if you look at like hyper-converged systems out there, there is nothing but Ethernet in that system. So that's a great use case for using something like Ethernet to tape, because it drops right in. You don't have to have separate, data mover servers and that kind of stuff that would give you some bridge to get to something like fiber channel.
Yeah, good point. So last question of the panel. When you think about exascale, we can do it from compute, storage. This is kind of wide open. Robin, we'll start with you. You have El Kappa 10 coming over 2 exaflops. What's going to, while you're retired, what's that aha, oh no, moment that you're going to have when you think about what's coming down as far as exascale and exabyte storage? What's keeping you up at night?
So when I'm sitting on a beach drinking a beer thinking about El Kappa 10, I really do worry about this mismatch in the rate that the investment we're putting into storage versus compute. There's only so many dollars. They want to spend it on compute. And when I point out that sort of disparity in the ratio of storage to compute, the answer is, well, we want to spend our money on compute, not storage. Users are going to have to change the way they view I/O. They're going to have to adopt these in situ methods and such. And I do sort of agree with it, but how do we get there? I mean, again, when you go to users and you tell them they're going to need to change the way they do I/O in 5 years, they're going to be like, get back to me in 4 years and remind me of that. But when then you get back to them in 4 years, they're like, it's too late. We don't have the time to do this. So I think it's going to be a big challenge in users figuring out how they can change the way they view I/O and their overall workflows to be able to process data before it gets written out to an archive where they're never going to be able realistically to pull it back in and process it at the end of a compute campaign where they've run for a month and they've generated 50 petabytes of data. It's just not going to be feasible. So that's a challenge.
Yeah. James, how about at Los Alamos? What's going to keep you up at night as far as exabyte exascale computing?
Yeah, I think one of the things that's probably is concerning, because it's a problem now, is dark site problem resolution. When something goes wrong with equipment or hardware, and the vendors just say, oh, well, just send us the logs. It's like, well, we can't just send you the logs from our site. It's got to be whittled down to maybe a few hundred lines or something, where a declassifier is going to be comfortable saying, okay, I'm willing to take this out of that environment and send it to you. It's in an open environment where it's not a big deal to just to transfer, upload a couple megabyte or gigabyte log, bunch of logs. That's one thing, but when something goes bump and you get that request and it's not going to happen, and then you have to deal with trying to get things figured out. So I think the more that vendors end up making their products more resilient and be able to troubleshoot items remotely without them getting the typical information that they would like to have to make it easy on themselves. So either providing tools for the engineers in the dark side to run. So that's probably one of the big things I would be concerned about, is just how do you solve problems when you can't easily transfer information in and out of the site you're trying to troubleshoot.
Well, that's the right guy on the call, because he's the one that keeps the list of stuff. I would ask you one other thing though before we jump off that. When you think about storing that exabyte of data, or if you're going to get to that, do you move to a fail-out architecture versus a fail-over architecture? Do you look at resiliency at the two copies, maybe not in the same subsystem, so you can get to one or the other because when you do think about an exabyte, if you have 100 petabytes, that's 10x, right? It's
right.
It's could be 10x the headache. It could be 10x the manpower. It could be 10x the time that you're working on it. So do you make architectural shifts, or do you just say, I keep scaling to Robin's point, her problem may be that they've taken a really small car and put in a giant engine in it, even though the whole car, which is the data center, that giant engine is going to flood the rest of the car because it's going to output so much data. They're going to have to do something different. In your case, you're starting at 100, maybe going to 500. What do you do differently? Anything differently? On the loss, do you train your users to get rid of data? Do you store less? Do you?
Yeah, I think there's going to have to end up being a multi-pronged approach. I mean, definitely we'll have to scale up the current capabilities. At our site, we have a little bit of geographic dispersion where we have things in different buildings and other things. So, but increasing bandwidth and floor space concerns are going to be going to arise when we try to grow to that thing. So it's just going to be kind of I think it's going to end up being an iterative approach where we see where we can, what makes sense to, our current, user base.
Matt, I'll let you close us out with any other verticals that you're thinking about. What are they doing that's going to help solve this problem? Any unique approaches you're seeing yet?
I don't think we've seen anything, really unique outside of possibly what they're doing in exascale computing, and they are, because they own all their own code, everything else, they're going to try to do things in the cloud, with all their storage, disk, tape, everything else, to use it more optimally. And they can do that because they can change anything, right? So that's
probably hyperscale, the cloud vendor.
Yep. So if you see, cloud vendors will probably try some unique things, and hopefully those ideas then trickle down more into, individual users out there with large archives themselves.
Good. So that's it for the questions. Any other comments that anybody has to make about the exascale panel that we did, or what's coming and how you're going to solve it? If not, I'm going to hand it back to Bob.
Hey, well, I'm not going to let anybody off the hook yet, Matt, because we had a couple of questions and comments come in. One question that came a little earlier, and Robin, you're in the hot seat because they called you out specifically. It says, Robin talked about changing user behavior in how, when they store. Is there a way to mandate that? Have storage quotas worked, or is there too much pushback?
Actually, I just realized at the end that I had not mentioned quotas. We do have quotas on our archives and our file systems, and for a very long time we didn't. I have a chart, I'm not going to show it to you, but our archival storage rate was going like this, and then we implemented quotas, and now it's going like this. We simply had to explain to users that we cannot afford to store everything, right? And it was a behavior change, but it's one that at this point users have accepted. The same thing on our file systems. We used to let users write as much as they want, and then when it got to a certain percentage full, we would tell them we were going to purge, and they would have to rush and clean up. And so everyone would try to clean up at once, and they were pounding on the metadata servers, and they were affecting performance, and it was very bad. So just recently, we put file system quotas in place, and it lets users deal with problems, you know, sort of in a staggered fashion. And we have users that are very important. Not that all of our users aren't important, but some are more important than others, and we have tiers of quotas for the file systems, for the archive, and if someone needs a bigger quota, their manager just signs off on it, and we give them a bigger quota. So at the end of the day, we're never going to just cut someone off, but you know, it's really hard to, you know, tell your users who you're there for that you're going to cut them off, but at some point, you know, they do manage to adapt to change, and we've had to do that.
Great. James, have you had any experience with that? Any that you would contribute as well?
Not too much on that side. I deal more with operations. We have a consultant group that tries to interface with the customers and guide them along, you know, what we need them to do if things are getting, you know, out of control.
Gotcha. Okay, I'm going to skip ahead one question just because, Robin, you touched on it again. The question was, in essence, are there issues around metadata servers growing too large? And this came in when we were talking about letting users tag their data so that they could find it better. I think it's kind of like squeezing the balloon. Have you seen anything like that, any of you?
I'm not sure exactly what you mean. I mean, I can speak more to file systems than the archive. I don't know exactly how HPSS stores metadata. I know it uses DB2, and there's scale out capabilities within DB2 as metadata grows. Lustre is our primary parallel file system, and we've gone to a model of having multiple metadata servers, so definitely now have the ability to scale out metadata and load balance and all those things. And GPFS, our other parallel file system, has distributed metadata. It helps. And when we buy our next-gen platforms, we always have requirements around metadata scalability that we give to vendors that they have to meet. And for El Capitan, our partner is Cray. They have a lot of experience with Lustre, and they are doing work in that area to improve metadata performance. And because it's open source, they're contributing that code back. And anybody then who's running Lustre is going to be able to take advantage of those advantages. But like I said, we are also looking at a sort of an out-of-band metadata storage product that actually does use database technology that's designed to be searchable. So essentially consuming metadata as it's created in the file system, putting it in this database, and then letting users go there to do all their, you know, labor-intensive DUs and, you know, things like that they're trying to do to manage their space.
Gotcha. All right. Are any of you moving to object storage archives? Has object storage come up?
Again, I'm not the HPSS person, but the HPSS person has told me that that is something they are looking at. You know, any development that gets done in HPSS has to be approved by, you know, it's a consortium, so IBM is part of it. They propose ideas, but they are looking at potentially proposing some sort of a RESTful object-like interface into the archive, because we are starting to see users who are interested in object store. So providing maybe that same interface into the archive, we think there might be some interest for that in the future.
Great. All right, that wraps up the questions. Katie, I believe we have a couple of drawings to perform. Thank you to everyone on the panel. We appreciate that and appreciate your time today. A couple of final drawings, Katie. Do we have names for, and I think I was incorrect earlier, I said that was the last of the $50 gift cards. We're going to draw for a $50 gift card as well as a $250 gift card right now. Is that correct?
That is correct. All right, so the first $50 gift card is going to Domingo Espinet, and then the grand prize of $250 is going to John Haddon.
All right, congratulations to you all. I want to thank everyone for joining us today. We're getting right to the top of the hour, so we'll be signing off. I wanted to also let you know next month, I believe it is November 17th, we will be having a webinar specifically on ransomware. So if you were interested in some of the stuff that Mark Usry brought up from SMR companies, definitely join us. That will be November 17th. You'll be getting invitations if you're on this list. And once again, thank thank you to everyone. Congratulations to our winners, and congratulations to everyone for spending this time to talk about a very important topic with us. We appreciate it. See you next time.